also seen some project related to the churn prediction, right? Project related to the churn prediction by using the logistic regression. So let's go and understand the logistic regression. Then we're going to decide details about the our project. So logistic regression is a classification technique, but since in the name itself it's called as a regression, but it is a classification technique where we have to do some of the classification tasks by using the nonlinear transformation. So you can see in this image, you will get nonlinear transformation for the logistic regression. We can also call it as a logistic curve for this matter. And for the linear, we also another model called the linear regression. We're going to be get maybe the upcoming classes as a linear model. We're going to be showcased as per the regression techniques. So it completes a linear model when we are going to separate any kind of the two class classifications, or but it is a regression mechanism, not a classification mechanism as a linear model. But the logistic curve or logistic model is going to be help us to understand to separate any class classification, whether it is a binary class classification or the multi-class classification. Let's go ahead and understand what are the different mathematical functions and how does logistic regression going to be help us whenever you have a binary class classification in your data set. So I am on the page of Medium blog. So where he is going to be explain some of the mathematical terms. I also taken some of the images what I have written by using the mathematical formulas. So let's go in some of the geometric intuition and also going for some of the loss interpretation of this model. So we can tackle out logistic regression with the three interpretation. One is a geometrical, and when another one is a probability interpretation, and another one is loss minimization. I can say we're going with geometric interpretation first, then we have to go with maybe the loss interpretation. Somehow that going to be help us by using this diagram. So let's focus on the geometric intuition. How does that going to be help us, and what are the different terminologies we are going to be used this? So let me take you this in a snippet. So you have two classes here. Okay, so one is the positive classes on the side of hyperplane, and another one is the negative class classification. We can represent it by using the positive, and then for the another class we can represent by using the negative. So how do you separate by using these two classes in your hand? So you can separate by using the plane, you can separate by using line like this, or separate by using the line like this. What if you have a point on this side as a negative point, and what if you have a point on the right side or the positive point in the negative end? So in this case, how do you tackle out by using the logistic regression? Let's go and check out this example. So here you can see we just drawn some plane here. It's corresponding to separating two data points or two different classes what we had. Let's take this as example for the positive and this example for the negative. So we separated by using the plane called P, or we can also called as a pi for that matter. Let's use our terminology is called pi. So I have a plane with pi, and I would also call something called as a norm perpendicular to this plane. We can also call it as a norm. I hope you know about the norm. So we can represent it by using W transpose. I have a W pi p, and with corresponding to the norm, I will write it as a which is perpendicular to our plane, which is also called as a W transpose. So okay, everything is set up. Whenever you have positive points and also the negative points, we draw a plane. According to that, we also draw the normal. And how do you calculate somehow to whenever some of the points come across with the negative side and also come across with the positive side, how do you calculate, and what are the interpretation between the geometric for the logistic regression? So if I have a let's take this is the xq value. This is unseen data point in your training data set, and corresponding to the negative side also we have an unseen data point. So what exactly the logistic regression will do here? It will take a distance from this point to hyperplane. Okay, it will take a distance from a point, that unseen point or unseen data point to the hyperplane, and it will calculate the distance. Let's take the distance we'll get. Okay, so the distance you will get, then what it will do, it will take and transports corresponding to your yi. These are the yi's, obviously. So yi is having around you have a data set with positive and also the negative results. So here we are not considering as a zeros and one for any kind of the label results. In the probabilistic interpretation, we can conclude as a zeros and one, but geometric interpretation, we can conclude it as a positive and the negative results. So this is a very interesting ideas whenever we do geometric interpretation. So I hope you know about something called as a distance. You can say distance of a point from a hyperplane. We're going to be get as a W transpose X by norm of the W, the distance from a point to a hyperplane. So this is the distance we are going to be get whenever you calculate the distance between the query point to the hyperplane. So let's go and discuss on this blog. He explained very brilliant with respect to some of the equations like this. So distance between a point to the hyperplane is W transpose Xi, and by the norm of the W. We're just calculating the total norm of the W, right? So what will happen if you take a distance between a point according to the plane, it is almost perpendicular, like we just now discussed with corresponding to the norm of the W. So it is also perpendicular. At the time of its perpendicular, norm of the W is going to be equal to 0, right? Which is going to be equal to 0. Or you can also, sorry, it is going to be equals to 1, the weighted vector of the norm W. So in this case, the norm W is going to be always 1 because of the perpendicular. So you will eventually get the distance W transpose Xi. This is the left, you're going to be left out with that. So whenever you got W transpose Xi in the positive side, that is greater than 0, the classes becomes as a positive. Whenever you get the W transpose Xi is less than 0, the class is going to be negative. So like that, you made some of the assumption by using this distance calculations. The distance is greater than 0, you will make as a positive. The distance is less than 0, you will make it as a negative. So like that, you make some of the assumption with regarding the logistic regression. How come that going to be helpful, and what are the different statistics we are going to be handled together? So these are the 4 cases we are going to be handled together. One is, if suppose you have a xq value is positive. So let's take this diagram again. So you have a xq is positive and ya is negative. At the time, what will happen? I hope you already know about some of the probabilistic interpretation between the positive and the negatives. So you have a yi with corresponding positive result, and while computing your W transpose Xi is positive. So what will happen if you just directly multiply this together, yi into W transpose Xi, you will get the positive result at the positive query according to that. This is the first case study. And what will happen if you tried with yi negative along with the W transpose Xi? That is that you're just predicting as the actual class values as a negative value, but you are predicting as a negative. At this time, you will get the positive result. That means W transpose Xi is going to be greater than 0 because of the negative going to be multiplied together. So similarly, you can see we are just taking the yi is a positive and W transpose Xi is a positive. You will get, if you just multiplied, you will get the results is greater than that. That means you're going to be get as a correctly positive points. And whenever you take yi is positive and W transpose is going to be negative side, that means in this case, this is the class variable we are just considering without any interpretation. And you will go eventually going to get, whenever you multiply with positive and negative, you will going to be get as a negative results. That is incorrectly classified points. And you are predicting value, or you're assuming as a yi is negative and your actual class label is a positive. So at this time, obviously negative into positive, obviously negative results. This is also not incorrectly classified point. So whenever you take as a negative results as a yi, this is the assumption you make, and this is the actual class label we have, the negative result. Obviously negative into negative is a positive. That means you will correctly classify the points whenever you have a negative result, and also the whenever you have a positive and a positive results. So that means you can see somehow we are having some assumption to get rid from yi positive and also the yi negative. So in this case, you can see incorrectly classified points is not eventually calculating the corresponding predictor values, but eventually calculating only the corresponding predictor values is yi w transpose xi is greater than 0. You can see the w transpose and xi is greater than 0 for this case and for this case. That means we are just maximizing the distance. So we are corresponding to maximizing somehow distance between the actual class labels and the predicted class labels. So for that, we can write some of formula like this: argmax of totally yi into w transpose xi. We need to maximize this all the data points, whatever the data points corresponding to our independent labels in our data set. So for that, we just write argmax of w and maximizing this lambda. So here we are going to be get yi's in our data set, xi in our data set, but w transpose is only the scalar part. This is ideally going to be changed every time, right? So these are constant, these are the constant. So eventually maximizing this corresponding wi, that is the norm of the w, we just now shown, right?